We said yesterday that if we have an object that is fairly heavy, it will cause its own gravitational field. Let's make our heavy object the Earth. That gravitational field is what we call a radial field. It points radially toward the Earth, and it looks something like this. Now, there doesn't have to be anything exposed to that gravitational field, but there could be. If there is, maybe it's right here. Maybe it's a red board marker at that spot right there that's exposed to that gravitational field. We now have two objects. We have the Earth and we have the board marker. Which one is it that's causing the field? The Earth. Which one is it that's experiencing the field? The board marker. So if we have information about the Earth, we would use what we call the producer equation to find the gravitational field, gm over r squared. If we have information about the board marker, what experiences the field, then we would use what we call the experiencer equation to find the value of the gravitational field. Notice that m appears in both equations. The black m here, the m that appears in the producer equation, is the mass of the producer, which is in this case the Earth. If we are using the second equation, the mass that appears in that one is the red mass, the mass of the experiencer, which in this case is the board marker. Which equation is better? Which equation is more valid? Well, there's no answer to that question. They're both valid. They're both always valid when you're trying to find a field. It's just a matter of what you're given. If you know more about the Earth, or whatever your producer is in a particular question, then use this one. If you know more about the board marker, or whatever the experiencer is, then use this equation. The bottom line is, the gravitational field, or that influence, or that region in which a force could be felt, the gravitational field is the same at this spot, right here, whether we look at it from the perspective of what causes the field, or whether we look at it from the perspective of what experiences the field. Now, what do you do if you have information about both? Let's say I know everything about the Earth and I know everything about the board marker. Which one do you use? Doesn't matter, right? Same field, doesn't matter which one you use. Whichever one ends up being the most convenient for you. Does that make sense? We had 3 questions for homework last night. They were on page 218. We wanted to find in question number 1 the magnitude of the gravitational acceleration of the satellite. What's another word for gravitational acceleration? Now we're calling it gravitational field, right? I want to do question number 1. Is there any other ones here that you want to do as well besides question number 1? Or are we good with just that one? Okay, let's do question number 1. It says a satellite orbits Earth at a distance of 3 times RE above the Earth's surface. We talked about the meaning of that yesterday. 3 times RE. What is that? 3 times... Adam? Yeah, 3 times the radius of the Earth. Now, how many Earth's radii is the satellite from the Earth's center? Yep. 4. 4 times the radius of the Earth. So what you want to do in this question to determine what the value of r is multiply 4 times the radius of the Earth, which is, as you can see, 6.38 times 10 to the 6 meters. That's what we want, right? We don't want the distance above the surface of the Earth. We want the distance from the center of the Earth to where we're trying to find the field strength. We'll figure that out in just a second. What else do we got? We got the mass of the Earth is 5.97 times 10 to the 24 kilograms. And we want to find the gravitational field strength at that satellite that's 3 times RE above the surface of the Earth. All right, tell me, in this problem where we have the Earth and the satellite, what's the producer, the Earth or the satellite? What causes the field? Ireland, what causes the field? Is it the Earth or is it the satellite? Good. So the satellite would be the experiencer. Good. Liam, what do we know more about? The Earth or the satellite? The Earth. Yeah. So let's use the producer equation since we know more about what causes this field. Let's get the value of r here first. and then we'll sub everything into that producer equation. R is 4 times 6.38 times 10 to the 6. Gives us 2552, 0.0000 meters. And now let's sub them into that producer equation. Mass of the Earth would be 5.97. Divided by, what, 2552,0000 squared. Let's plug that into the calculator here and see what we get. 6.67 times 10 to the minus 11 times 5.97 times 10 to the 24 divided by, use some brackets here, 2552,0000. We could have gotten away without brackets there, actually, but that's okay. 0.61. How many digits should we be here? 3 digits. 0.611. We're going to say newtons per kilogram, although you could use meters per second squared as well. Now, that's using information about the Earth. What if we had have known information about the satellite up there? What if we had known the force of gravity experienced and the mass of the satellite? And we had to use the experiencer equation. What do you think we would have gotten for an answer? Same thing. The field caused by the Earth at that point is the field experienced by the satellite at that point. So in this case, we only had information about the producer, but if you have information about the experiencer, it's just as good. In fact, you could argue that it's easier because it's a simpler equation. Here's another question for you. This one says, calculate the gravitational field strength if a 70 kilogram person has a weight of 500 newtons. Determine how far above the surface of the Earth a person would need to be in order to experience this field. So this question in particular, I think it's a little bit tricky as to what we're going to use where. Let's draw a little picture to maybe help us to visualize this a little bit. This is the Earth. And we have a 70 kilogram person somewhere above the surface of the Earth. Maybe they're in an airplane, maybe they're skydiving, maybe they're in the International Space Station, maybe they're going off into space. I don't know. They're above the surface of the Earth. The mass of that person is 70 kilograms. The mass of the Earth, we know, is 5.97 times 10 to the 24 kilograms. The weight of this person, what's another word for weight? What's the same thing if we look at our physics thesaurus, our imaginary physics thesaurus? Another term that means the same thing as weight is? No. Apparent weight is normal force, but actual weight is gravity. Yeah, it's gravitational force. So I'm going to label this not as weight, but I'm going to label it as gravitational force. And we're going to find this value right here, the distance above the surface of the Earth that the person is. What do you want to do here? We've said this 1,000 times by now, right? There is nobody in this room that has no place to start here. You know, if I'm dealing with gravitational fields, there are 2 valid equations. There's the producer equation, there's the experiencer equation. Even if you're not sure which one to use, write down one of them. And if you can, make it work. If you can't, then try the other one. Which one do you want to try first here? What do you know more about? The Earth or the person? What do we know more, Taylor? What do we know more about the Earth or the person here? The person. Is the person the producer or the experiencer? Right. So let's use my experiencer equation. But if you didn't notice that, that's okay. Try the other one. You'll find that you can't get anything from that right away. That's okay. Just go back to, eventually you're going to get back to this one. G is equal to F over M. The force is 500 newtons. What mass do I use here, the 70 or the 5.97? Braden, what mass do I use, 70 or 5.97 in the experiencer equation? 70. So 500 divided by 70 kilograms. Gives me 7.14286. And the units would be newtons per kilogram, or you still could use meters per second squared. That would be okay. I'm going to round that to 2 digits as a final answer. I'm just keeping the unrounded number there in case I need it for the second part of the question, which is asking me how far above the surface the person would need to be in order to experience that field. Good. 7.1. My guess is that I'm pretty far above the surface of the Earth. Why? Why is that my guess? Sydney, why do I think that I'm going to have to be pretty far above the surface of the Earth in order to have this field? Like G when you're close to the Earth is what? Right, and we're 7.1, so that means I'm going to be pretty far away from the Earth. Like probably not like hundreds of thousands of kilometers, but not like, the top of a 50-story building either. Right? All right, what do you want to do to find how far above the surface of the Earth the person would need to be? Yep. Sure, let's try the producer equation. Now, we did the experiencer equation, worked for us, got us what we wanted. Now let's try the producer equation. Let's rearrange that. We get G times R squared equals G over M. We get R squared is equal to GM over little g. And then, of course, we square root that. And we get R is equal to the square root of GM over G. 6.67 times 10 to the minus 11 times the mass of the, what mass would I use here, 70 or 5.97? Abby, what's the producer here, the Earth or the person? So what mass do I use here? Good. 5.97 times 10 to the 24 kilograms, divided by not 9.81, but rather 7.1428 newtons per kilogram. Make sure you square root that. 6.67 times 10 to the minus 11 times 5.97 times 10 to the 24, divided by 7.14 gives me this value. Let's square root. There's something wrong with that. What have I done wrong here? Yeah, but you know what? If I square root that, I'm going to get like... I've definitely made a mistake there. Oh, no, that's right. I missed the exponent there. I missed the 10 to the 13 there. Okay, that looks reasonable. 7.466448. So we're going to say, what, 7.5 times 10 to the 1, 2, 3, 4, 5, 6. 7.5 times 10 to the 6 meters. We predicted that it would be pretty far, right? And it is, right? Am I done? Oh, wait, I shouldn't have squared that off because I'm not done. What have I just found? Yeah. Good. The center of the Earth to the person. What am I looking for, Jen? Okay, so what do I got to do then? You got to what? I just solved for this. Nope. I just solved for this. I want this. So I have red. I want green. Maddie, what am I going to do? Let's subtract the radius of the Earth to get the green one. So let's go minus 6.38 times 10 to the 6 meters. The new radius, the one that I want to get here, the radius or the distance above the surface of the Earth, is that value minus 6.38 times 10 to the 6, which gives me 1.1 times 10 to the 6 meters above the surface. So sometimes we gotta add the radius of the Earth. Sometimes we gotta subtract the radius of the Earth. Sometimes we just gotta keep the number that's given to us, right? Yeah, Jen? I'm sorry? This one here, this is the producer one. So the first one is the experiencer one. We're using information about the person that feels the field, that experiences it. This is the producer equation. We're using information about the Earth that causes that field.
Okay, well, why did you divide by 7.1 in that one?
I divided by 7.1 because in the first part of the question, we calculated the field that was experienced by the person. Well, what caused that field that the person experienced? The Earth. So why can't we use that as the field caused by the Earth? Right? If I cause something and you experience it, then we can use the same number whether we're using an equation to describe you or using an equation to describe me. The person experiences 7.1. Why does the person experience 7.1? Because the Earth causes 7.1. Therefore, if I have the 7.1, I can use it in either equation.
Why did you use it there? Because in the equation it says that's where r squared goes.
Yeah, but I rearranged that, right? I rearranged it to solve for r. So I took this equation, took the r up by multiplying, the g down by dividing, and then I square rooted. Does that make sense?
Yeah, that's what
Okay, good.